Now that we've learned about measures of center, we're going to learn about standard deviation, which tells us how far apart our data values are. So we're going to start by looking at an example here. So in example 1, we have the lengths of 5 2-inch carriage bolts produced by some manufacturers. Okay, so in a factory, they're making these bolts that all should be 2 inches. But because of the way the machine works, they're not exactly 2 inches. So from manufacturer A, we get one that's 2.02 inches, one that's 2.01 inches, 1.96 inches, 2 inches, and 2.01. So if we wanted to find the average of those, we can do that here on the calculator. We could add them up. Or, of course, you could put them in L1. And divide by 5, since there were 5 of them. And we see that the average is 2. So if they're just looking at average, they do average out to what they want, but we know that they're not all exactly 2. Okay, and then we can look at manufacturer B. So they had one that was 2.2, one that was 1.7, 1.85, 2.1, and 2.15 divided by 5. Well, here the mean is also 2. But we could ask ourselves, and if this was a classroom, I would ask for some classroom discussion, which manufacturer is doing a better job making the bolts and why? And we could have some discussion, but I would make the argument that manufacturer A is doing a better job. And the reason for that is if you want a 2-inch bolt, you want each of your bolts to be closest to 2. And manufacturer A, the furthest it gets would be this 1.96, so 0.04. Manufacturer B, even though they average out to the exact same thing, this one, 2.2, that's 0.20. So that's 5 times as off as the one that was furthest off up here. So even though the average is the same, how they vary is not the same. Okay, so let's look at another example here. So example 2. So here we're going to talk about waiting times at a bank. So bank A has 3 tellers and each teller has a customer line. The waiting times of 6 customers at bank A in minutes, so 2 minutes, 8 minutes, 6 minutes, 3 minutes, 1 minute, or 10 minutes. And if you average these, so if you added them up and divided by 6, you would get that the average waiting time was 5 minutes. Not too bad, but the person who waited 10 minutes had to wait twice that average. Bank B has 3 tellers but only 1 customer line. And so their waiting time, 3 minutes, 5 minutes, 7 minutes, 4 minutes, 5 minutes, and 6 minutes. And if you add those up and divide by 6, again, you get 5 minutes. Now, again, we could have a conversation about which bank would you rather be at. Now, some people might choose bank A because there's that chance that you'd only have to wait 1 or 2 minutes. But there's also the chance that you'd have to wait 8 or 10 minutes, more than the average. Whereas if you wanted to know exactly how fast you're going to get in, going to bank B it's much more consistent. There, no one had to wait more than 2 minutes over that average of 5. So here, it's important to know that not only does the average or the mean matter, but how far things are from the mean, how much they vary, also matters. So we're going to talk about standard deviation. So standard deviation, the set of values, is a number that measures what we call spread. Or how far on average is each data value from the mean. So it's actually an average. It's a mean of how far each of the values are from the average, from the middle. So the larger the standard deviation is, the more spread out the values are. Now, if you had a standard deviation of 0, then all the data values in your set are exactly the same. That means there's no spread. Okay, so we'll also talk about the symbol. So the symbol for the standard deviation of a sample is just a little s. On your calculator, you'll see this as an SX. And that's the standard deviation you're going to use the most in this class. In the formula, it's the square root of the sum between each, the difference between each x value and the mean, squared, divided by n minus 1. Now, we're going to do this almost exclusively on the calculator because it's really not worth doing this by hand. It's far too easy to make mistakes. But let me just show you the work involved to convince you that it's a good idea to use the calculator. Okay, so we have these 4 data values, 5, 8, 11, and 36. The first thing we would do would find the average. So we would add them up. And divide by 4. So we see that the average is 15. Now the next thing we would do is we want to take each x value, subtract the mean from it, and square it, because we're going to add those all up. So we would take 5 minus 15 and square that. Well, 5 minus 15 would be negative 10, squared would be 100. 8 minus 15 would be negative 7 squared would be 49. 11 minus 15 would be negative 4 squared would be 16. And 36 minus 15 would be 21, which when we square it would give us 441. So next we would add those all up. So if you add up those numbers, you get 606. So what we've done here in our formula, we've done the sum of x minus x bar squared. So that's 606. And we're going to divide it by n minus 1. So n here is 4. So we're going to divide it by 4 minus 1, which is 3. And when you do the square root, well, when you do 606 divided by 3, you get 202. And that's 14.2. So our standard deviation is 14.2. The good news is it's going to be much quicker to do it on our calculator. Because as you can see, if you had a larger data set, this would take a long time. So using your calculator, the same way that we found mean, you're just going to scroll down a little bit. It'll be SX. So if we have these 6 data values and we want to use our calculator, and we round the same way we do the mean, one data place more than the data is given. So since these data values don't have any decimals, we'll round to 1 decimal. Okay, so we're going to go to Stat and to Edit. Remember to clear, go up and hit Clear and then Enter. So we're going to put these data values in. So once they're in, you're going to hit Stat, go over to Calc. You're going to do that a lot in this class. Hit Enter, go down to Calculate. Okay, and you'll see the 4th one down is the standard deviation. So here we're going to round it to 1 decimal place, so it would be 7.4. Now we could also talk about the symbol for, or the standard deviation of a whole population. This doesn't happen hardly ever, but you'll see the symbol sometimes it looks like an O with a bar. This is a Greek sigma, a lowercase sigma. So on the calculator, it's sigma x. And the formula looks very similar, except we're using the mean of a population. So it's x minus mu instead of x bar. And we divide it by n. Okay, but you're not going to have to do that by hand. Your calculator, if you had a whole population, the calculator also gives you that standard deviation. But in almost every case in this class, you will be using a sample, and so you're going to use SX. Now, this is just kind of a funny little rule, but it's called the range rule of thumb for a standard deviation. So if you only know the min and the max, a rough estimate for the standard deviation can be found by taking the range, which is the max minus the min, and then dividing that by 4. It would always be 4. So number 3 here says, for a data set, suppose that we only had the minimum value is 25 and the max is 92. Estimate the standard deviation. So we'd find the range by taking the maximum 92 minus the minimum 25 and dividing by 4. If you're doing this on your calculator, remember to put parentheses up top. So 16.8 is what we would have here. Okay, if we were doing this for the wait times, our maximum was 36 and our minimum was 5. Divide that by 4, we get 7.8. Which you can see wasn't too far from 7.4. Okay, so that's the beginning of the standard deviation.